Hi ladies, this is lesson 4.8 for geometry. It's about proving special triangle conjectures, and we're going to use a flowchart proof to do this. Again, we're not going to write formal paragraph proofs in this class, but flowchart proofs are a good way to kind of organize our thoughts in the proper order in which the conclusions are drawn. So we've worked with theorems and we've worked with conjectures, but now we have this new vocab term. It's called a lemma. And this vocab term is very similar to conjecture and to a theorem, but it's not really that important. It's kind of a stepping stone. So it's not important enough to get its own name. Like we have the vertical lines conjecture or the parallel lines conjectures about angles and stuff, but this lemma is a helping theorem. So you'll see we'll show how we know lemmas are true, and then we're going to use them to help show theorems are true. All right, so in this first part on your note sheet, you should see these instructions. So I want you to draw a scalene triangle and label it ARC, and then sketch the altitude, sketch the bisector, and sketch the median. And they all come from angle C in this triangle. All right, so if you remember, a scalene triangle has no two sides are congruent. So go ahead and on your note sheet draw that scalene triangle. I'll do one up here so you can see. So if you look at my triangle, all of those sides have different measures. And I'm going to label it A, R, C. All right, now it just says to sketch in the altitude, the angle bisector, and the median. So if you remember, the altitude goes from vertex and is perpendicular to the opposite side. All right, so let's do the altitude first, and we're going to label that CD. So from the vertex, and it's going to be perpendicular to the opposite side. All right, now the second step is to sketch in the angle bisector. So we'll do this one in kind of that greenish color. All right, so the angle bisector cuts or divides angle into two congruent angles. All right, so go ahead and on your note sheet, just sketch in. Again, you can construct it if you'd like to, but you don't have to do that. You can use your protractor if you want, or you can just sketch it in. So I'm just going to sketch it in. Well, I'm going to just estimate here. So I'm trying to divide this angle into two congruent. It'll probably be about here. That looks about right to me. Might be a little bit off, but again, it's just an estimate. All right, and it says to label that CE. All right, and then lastly, we're going to sketch the median of that triangle, and we're going to label it CF. So it's going to come from angle C. And we'll do that in this other green. All right, so median comes from vertex to midpoint of the opposite side. So if I was constructing this, I would first have to find the midpoint of AR and then draw a segment that connects C to that midpoint. But here I'm just going to estimate. So we'll use that same green color. I don't know which one it was. This one, it looks like. This one maybe. Alright, so this looks like about the midpoint of AR. So go ahead and draw that in, or sketch it in. And it says to label that point F. Alright, now let's look at these three segments. So we've got the altitude in purple, we've got the angle bisector, CE, and we've got the median CF. Are any of these special segments the same? It doesn't look like it. They're all on different, they all lead to different points on AR, and none of those segments overlap. So no, none of these are the same in this scalene triangle. Now if you look at your own, again, you should see that they're all different. If your triangle is actually scalene, all of these should be different. Now we're going to explore these same special segments, but we're going to look at isosceles triangles. So with your ruler and protractor, I want you to draw an isosceles triangle and label it AKR, where K is the vertex angle. So if you remember the isosceles triangle definition, has two congruent sides, and the converse of the isosceles conjecture says that if a triangle has two congruent angles, and in an isosceles triangle we call them base angles, the triangle is isosceles. Okay, so these are two different conjectures. Well, one actually is the definition of an isosceles triangle, and the other one is a conjecture that we looked at earlier this chapter. So you could use either one of these to draw your isosceles triangles. I'm going to use the base angles one because I think that that's a little bit easier. It doesn't really matter which one you use, but I think that it's easier just to measure the angles. So you can use a ruler to measure the sides if you want, or you can use a protractor to measure the angles. So I would start with a segment, and with the segment, and you can make yours 10 degrees, your angles 10 degrees, or you can make your base angles 40 degrees or 60 degrees, it doesn't matter. They will have to be acute, because with an isosceles triangle, the base angles are always going to be an acute angles because they have to be congruent. And in a triangle, the angles add up to 180 degrees. So the two angles that you construct are going to have to be less than 90 degrees, but it doesn't matter, just choose a measurement for those. Alright, there we go. So I'm going to make mine 60 degrees. So there's one 60-degree angle. Oops. And then here is my other 60-degree angle. Oops, actually that says 120. Let's try it again. There we go. Alright, so I've got my two base angles. Now I just have to make this into a triangle. So I'm just going to extend my sides so that they intersect. And you should use a straight edge for this. Okay, then it says to label it AKR with K as the vertex angle. And then the next step is to draw an angle bisector, KD, where D goes on to AR. So again, you'll need your protractor, or if you'd like to construct it, you can do that too. So I'm going to first measure my angle. So you'll have to put that perpendicular part of your compass, or of your protractor here so that I can actually measure this. And this measures at 60 degrees. Okay, so now if I want it to be half of that, I need it to be 30 degrees. All right. And then I'm just going to have to extend that side again so that it goes all the way over to my opposite side. Okay, so that's my angle bisector, that pink line, and then I've got to label it D. All right, now let's look at my triangle that I made, ARK, where K is the vertex angle. I'm just going to mark my congruent pieces. So it's an isosceles triangle. So I know that these two sides are congruent. And I know also that the base angles are congruent. And then lastly, KD is the angle bisector. So I know that this angle is congruent to this angle. So just mark everything you know, all the congruent pieces that you know. It'll help you answer these next couple questions. So the question is angle ADK congruent to RDK? So let's just outline that angle. And I'll use a lighter color so that we can see. And I'll use a dotted line. Okay, so is ADK, this triangle, is that congruent to RDK? RDK. Well, how do we show that two triangles can be congruent? So we have to use one of our shortcuts for proving triangles are congruent. So if you look at this, we have angle A is congruent to angle R, AK is congruent to RK, and then angle AKD is congruent to angle DKR. So this angle congruent to this angle, and then these two sides are congruent, and these two angles are congruent. So yes, these two triangles are congruent because of angle side angle shortcut. Now you could also say because they also share a side. So you could also say because side angle side. So the sides are congruent here, and then these two angles are congruent, and then this side is congruent because it's a shared side. So if they are congruent, then AD, actually that should say if they are congruent, then KD is the line of symmetry. So this should say KD is the line of symmetry for those two triangles. So using your ruler, determine if D is the midpoint. Well, you don't even really have to use your ruler for this. I mean, you can just to double check, but you don't really need your ruler because you just showed that the two triangles are congruent. So that means that corresponding sides are congruent. And if you have two congruent segments within a larger segment, that means that this is the middle. That point that divides that one segment into two congruent segments is the midpoint. So, yes, D is the midpoint of AR. So if D is the midpoint of AR, then what is the name for this segment, KD? So what do we call this purple segment if we know that D is the midpoint? Well, a segment that goes from a vertex angle to the midpoint of the opposite side is called the median. Okay, so now we know that KD is the median and KD is the angle bisector. All right, so the next question is angle ADK, is this angle here congruent to RDK? So are these two angles congruent? And if they are, how do we know that? Well, we know that the triangles are congruent. So if the triangles are congruent, then the corresponding angles have to be congruent. So if the triangles are congruent, then corresponding parts of those congruent triangles are also congruent. So that's how we know the angles are congruent. Now the next question is, are these angles supplementary? Well, if we look at this diagram, and I'm going to use just this green dotted line, ADR, that line, or those points, are all collinear. Okay, they all form one straight line. So that means that the two angles, those two angles that I just marked in blue, those are a linear pair. So if they're a linear pair, then they are supplementary. So yes, we know this. So now that we know that they're congruent and they're a linear pair, we know that they add up to 180. So let's call it angle A, for example. So if this is angle A and the other one is angle A, because they're the same, so they have the same measure. So that means that 2A equals 180, which means that they each have to be 90 degrees. All right, so now that we know this is 90 degrees, and I'll actually mark it 90 degrees. And we'll do that in red. All right, so this is 90 degrees, and this is 90 degrees. So if this KD is perpendicular to the opposite side, so now we know that it's the median, and it's the angle bisector, and it is the altitude. So now we've just proved this lemma. So the bisector of a vertex angle in an isosceles triangle divides the triangle into two congruent triangles. Which helps us show the vertex angle bisector conjecture. So in an isosceles triangle, the bisector of a vertex angle is also the median and the altitude of that triangle. So now if you're looking at this flowchart, we've already done this, but let's just fill in the missing pieces. So as if triangle ABC is isosceles, then AC is congruent to BC. Okay, that's marked. And then if CD is the angle bisector of angle C, then, so here's the first part, if CD is the angle bisector of angle C, then angle 1 is congruent to angle 2. So that's just what the bisector means. It means that it divides the triangle, or it divides the angle into two congruent angles. So we also know that it's an isosceles triangle because that was given. So now we can say that CD is the same segment, or CD is congruent to CD because we know it's the same segment. So we're looking at this line here. Okay, so if we know it's the same segment, then we can show that the triangles are congruent. So we have a side, an angle, and a side. All right, just as a side note, you want to use side, angle, angle, side, angle, side, angle, angle, or side, side, side to show that triangles are congruent, like we're doing in this case right here. We're showing that these two triangles are congruent, and you're going to use that CP-CTC theorem after you show the triangles are congruent to go back and show that a side or an angle is congruent. So here we know these triangles are congruent because of CP-CTC. So the next one, this is a flowchart proof for that theorem that we just looked at, the vertex angle bisector conjecture. So if we know the triangles are the triangle is isosceles, then we know it has two congruent sides, and it also tells us that CD bisects angle C. So first part is given, angle ABC is isosceles, and CD is the bisector of angle C. Now the second part, we already did this. We showed those two triangles were congruent from that last flowchart, lemma A. So now we can show that angle 1 is congruent to angle 2 because of the CP-CTC. So we're going to use, again, we use this after we already showed triangles are congruent. So then that helps us, so we know that angle 1 and angle 2 are right triangles because congruent supplementary angles are 90 degrees. And then number 7, how do we know that they're perpendicular? Well, because they're both. We know that CDB and CDA are 90 degrees, so that's the definition of perpendicular. And then lastly, we know that CD is the altitude because it comes from a vertex and is perpendicular to the opposite side, and that's what the definition of altitude is. All right, and then let's look at this last extra example. So I know this video is getting kind of long, but we split this lesson up into 2 different classes, but it's going to be one long video. So this extra example, we know that the perimeter of the triangle is 11 centimeters. So the perimeter is the sum of all the sides. So just so you remember your definition, perimeter is the sum of all 3 sides of the triangle. We know that that's 11 centimeters. And then we also know that YL bisects, this should say angle XYZ. And we know that XL is 2.1 centimeters. All right, so let's just mark what we know. If YL is the angle bisector, then what we just proved was that L is the midpoint because those 2 triangles are congruent. So we know the triangles are congruent because we have angle, side, angle. So the 2 triangles are congruent. So if this is 2.1 centimeters, then this also has to be 2.1 centimeters. All right, we also know that this triangle is isosceles because these 2 sides are congruent. So if those 2 sides are congruent, then these 2 angles have to be congruent, which makes this 40 degrees. Which actually we don't really need to know that, but we do need to know that it's an isosceles triangle. Okay, so let's just call this side A. CY, we're just going to call it A, so it's just easier to work with. And then if this side is A, this side is also A. Okay, so we know that the perimeter is equal to this side, which is 4.2, plus A, which is 2A. Okay, then if we do a little bit of algebra, subtract 4.2 from both sides, we get 6.8 equals 2 times the last side that we don't know, which we're calling A. And then to solve for that side, we're going to divide both sides by 2. So it gives us A equals 3.4 centimeters. All right, so X, Y, that's our A. We just solved that. That was 3.4 centimeters. All right, now our second goal is to find the measure of angle LYX. So LYX, we're looking for the measure of this angle here. Well, since we know that it's an isosceles triangle and these 2 sides are congruent, that tells us that these 2 angles are congruent. And since we know that this is a line, this also has to be 90 degrees. We know that the sum of all the angles in a triangle equal 180 degrees. So, and we'll just call this B, just so it's easier to use for our formula. So 180 degrees equals 90 plus 40 plus B. So again, we can do a little bit of algebra. So we're going to subtract 90 and 40 from each side, which if you total those up, that's 130. So So 50 equals B. And again, B is angle LYX. So that's 50 degrees. So please jot down any questions that you have and we can go over them next time I see you in class. Thanks.